keep going there. Okay, so just quickly to show you the pictures. For number one, the thing that we learned yesterday was cyclic quads, that the opposite angles of the cyclic quad add up to 180 degrees. So here, they gave us 150 degrees over there. Sorry, it is quite small, but let me just zoom in. They gave us that this is 150 degrees. Now we need to find x and then y. All right, so if this is 150, we can see that this is at the center. X is at the circumference. So x has to be half of 150. So that's why x is 75 degrees because of angle at center. That whole reason I'll show you now. Now that we have x here, do we notice that we have a cyclic quad, this big shape? All four vertices of this quadrilateral lie on the circumference of the circle. So we can say straight away it is a cyclic quad. So we know that the opposite angles must add up to 180. So x and y together should equal 180. So if x is 75, y is going to be 180 minus 75, which is 105.
So now
Yes.
the top by two angles around the point.
Yeah, you could have. That's fine. Yeah, that's how we did it before we move on.
Yeah.
Okay, in number two, you just had to use opposite angles of cyclic quad for both of them. So we have x is opposite 78. So x has to be 102, because 102 plus 78 is 180. And then y, the opposite angle is 79. So this must be 101, because 101 plus 79 will give you 180. And guys, because they're both the same reason, I just wrote it in one line. So x equals 102, y equals 101. Opposite angles of cyclic quad, like that. You're allowed to do that. They won't take off any marks for that. Number three was a bit of an application question because they didn't actually give us any values, but they gave us the opposite angles in terms of the same variable. So they said here 5x and 4x, these two are opposite angles, so they must equal 180 if I add them. So you could set up an equation there. Same thing here, y plus 2y is also 180, all right? So I did that for both of them. And then you can solve for x and solve for y in both of those equations. Any questions so far? Okay, number four. Let me just show you the picture. We had that is 140. So x is the opposite angle in this cyclic quad. So x must be 40 degrees, right? So that these two equal 180 if I add them together. So if that is 40, the angle at the circumference, the angle at the center must be double 40, 2 times 40, so 80 degrees. Right, so x equals 40 degrees, opposite angles of cyclic quad. Y equals 80 degrees, angle at center equals 2 times angle at circumference. Okay, we are now practicing actually putting down the correct reasons. So please, from here on out, we need to keep doing that. Yeah. This. Yeah, so 180 minus 96 is 84, isn't it? Had me doubting myself there for a second. All right, number 5, it was a bit irritating that we had to do everything in one step. It would have been nice if the vertices were labeled, because then we could actually write it out separately. But I just want to show you guys my thinking here. We have that this angle is 42 degrees and we have an isosceles triangle, right? So that angle will also be 42 degrees because of angles opposite equal sides. Then we can find this angle by saying 180 minus 42 minus 42, right? Which will give you 96 for that one. So what I'm saying is if they gave us labels, letters on each of those points, we actually could have written it down like step by step, okay, which would have been nice. So we could have said that this angle, say it was an A or something, we could have said angle A is 180 minus 42 minus 42, angle sum and triangle, angles opposite equal sides. And now we have an a cyclic quad here, all right? Even though it looks a bit skew, it doesn't matter, hey? As long as all 4 vertices lie on the circumference of a circle, it's a cyclic quad. So now that angle 96 and x, if I add them together, must equal 180. So x is going to be 180 minus 96. Okay, so that's what I wrote, like all in one step. This is 180 minus 96 degrees. Okay, and the 96 I got by saying 180 minus 42 minus the other angle, which I know is also 42 because of angles opposite equal sides. Okay, so I wrote all 3 of those reasons there: opposite angles of cyclic quad, and angle sum and triangle, and angles opposite equal sides. Okay, and then the answer there is 84. Then number 6, I just found the 2 y's as different values because they were different in the 2 triangles. So I'll show you quickly. So sorry about that. I didn't realize that before I set it. So here, you also couldn't actually find x before you found one of the y's, which was a bit strange. Do we agree that the easiest y, well, they're actually both equally easy, I suppose. If you did opposite angles of a cyclic quad with this bottom y, that's 80, so this one has to be 100, right? So this y is 100 degrees because of opposite angles of cyclic quad. But then if you calculate this y, so I'm guessing they wanted to make this a z or something. One of them was supposed to be a z. So if you calculated this y, we have that triangle, right? So you would say angle sum and triangle, y equals 180 minus 80 minus 70, which will give you 30 degrees. I'm just now realizing that you could also get 2 different values for x, I'm guessing, maybe not. For x, what did I do? I did angle sum and triangle in this triangle here. So x is 180 minus 100 minus 45, right, which is 35 degrees. Would it work the other way around? X plus 70 is, so let me just check quickly. Minus. Yes, okay, yeah. Or you could have said opposite angles of cyclic quad. I'll show you now on the picture. And in geometry, there isn't ever a method that's more correct than another method, all right? Whatever you see first, you do, as long as you write it out properly and you write your reason down, it's fine. So here, we now know that this whole angle is 75, and that angle is x plus 70, all right? So x is going to be 180 minus 75 minus 70 because of opposite angles of a cyclic quad there. So then you will also get x equals 35. All right, in number 7, I just relabeled them because, I mean, there were 3 y's and all 3 of them were different, so it irritated me. So I'll just show you quickly on the picture. I kind of relabeled them in the order that I found them, I suppose. So I don't know what you guys did. If you maybe want to write it down or something. If this was a diameter, right? Because there it wasn't very clear. I'm not sure if you guys could make that out, but that was actually the center of the circle. There was a little point there. Okay, that was like not colored in basically. So this line is actually a diameter. And we know that a diameter always subtends a 90-degree angle. Okay, so I said that that angle is 90. So you should have one of your y's, I suppose, equal to 90 degrees. The reason would be angle in semicircle. So that was my x that I decided to just make it an x. All right, angle in semicircle. Then the one that I kept as y, this one here at the top. Again, now this looks like a funny quadrilateral, but it is still a cyclic quad because all 4 points lie on the circumference. Okay, so those 2 angles are opposite. So if this one is 40, then that one must be 140 because the 2 of them must add up to 180. So y is 140 degrees, opposite angles of cyclic quad. And then the other one I made z. Oh, sorry, this one here. If I know that that's 90 and that's 40, All three of these angles must add up to 180 because they are three angles in a triangle. So I did that. I said 180 minus 40 minus 90 will then give me 50 degrees. Angle, sum, and triangle. Any questions on that one? All right, then number 8. For number 8, they gave us two isosceles triangles. So that bottom one is isosceles and this top one is isosceles. I didn't actually really work in this bottom one at all. I just saw that it's a cyclic quad. So if that's 80, this one must be 100. Right? Opposite angle of the cyclic quad. And then this angle Y will be the same as that angle there. So we can do that isosceles triangle thing where you say 180 minus 100 is 80 degrees. So these two angles must add up to 80. But because they're equal, we can divide them by 2 or that by 2. So each of these angles will have to be 40 degrees. Right? So that's what I did. So I said 180 minus 100 degrees. Now, how did I get this 100? By using opposite angles of cyclic quads. So that there is the reason for getting the 100 degrees. Why am I minusing it from 180 now? Because of angle, sum, and triangle. And why am I dividing by 2? Because of angles opposite equal sides. Yes. Yes, it is, yeah. You have to say angles opposite equal sides. Okay. They don't actually give the marks at the end of matric for isosceles. All right, so that one was y equals 40. Yes.
Do you have to write the 180 minus 100?
No, you could have just written the answer straight. As long as all three of those reasons are there, that's fine. Okay, I want you guys to now quickly in class work on the rest of this exercise. Actually, okay. Yeah, okay. Yeah, I'm checking now if it happens in any of the others and it doesn't look like it. I actually just want you guys to do 9 to 12. All right, so I'll put them on the board for you. Just do 9 to 12 now. We're still going to mark them and then do some new work. All right, so this isn't the end of the lesson, please. I want you to do 9 to 12. You can just carry on underneath number 8 or wherever you stopped. Okay, and then we'll mark them together and then we'll carry on with some more stuff. Yeah, I don't know him. Very annoying. 9, 10, and 12. All right, so for number 9, you actually couldn't use any cyclic quad stuff because it wasn't a cyclic quad. All right, so I just did in one step again. This angle over here is 360 minus 130 is 230, hey? 230 degrees, this one here, because of angles around a point. And that is the one at the center. So that one is going to be half of that. All right, so 115. You see what I did in my calculation? I said 360 minus 130, that gives me that angle. And then you divide it by 2 because of angle at center. Then for number 10, you had to first work with your parallel lines. So here we have co-interior angles, right? The C shape or the U shape. And we also know that those two must then add up to 180. So if this is 120, this is going to be 60 degrees, right? Co-interior angles, guys, if they haven't labeled the parallel lines, you have to say parallel lines in your reason. You can't just say co-interior angles. So you have to state that the lines are parallel. So literally parallel lines. Please add that as a part. Then I did the same thing, but just kind of the other way around. For finding y, you needed to do angle at center to find this reflex angle here. So what's double 120? 240. All right, so that angle is 240 degrees because of angle at center. So then y is going to be 360 minus 240 because of angles around a point. Or you can also say revolution. Okay, so that is how I got 220. Revolution is just as correct. Then number 12 was a nicer one. Okay, again, we have parallel lines, guys. Normally, they don't give you parallel lines if you don't have to use them. Okay, so that is a good hint. If there are parallel lines, you need to be on the lookout for F shapes, Z shapes, C or U shapes. So we have an F shape that's kind of lying on its back here, all right? So corresponding angles are equal. So this one is also 103. Corresponding angles, parallel lines. Okay, you have to add that parallel lines if they haven't labeled the lines. And since we're done, we will just keep in mind. Then Y, this is the second cyclic quad thing, which I just explained at the end. This 103 degrees is an exterior angle of the cyclic quad because it's a side that's been lengthened, and then it's the angle on the outside. Now, the theorem says that the exterior angle of a cyclic quad is equal to the opposite interior angle. All right, so if you can look for the angle that's lying next to it, the angle that is then opposite that angle, those two are equal. All right, so Y is going to be 103 degrees. And guys, it works like that because you could find this angle using angle sum and triangle. It's not, sorry, angles on a straight line, right? By saying 180 minus 103. So this one would be 77. And then opposite angles of a cyclic quad must add up to 180. So this one is then going to be 180 minus 77, which is again 103. So instead of doing that in 2 steps, which is fine if you want to do it like that, if you forget about exterior angle, but you can just do it in 1 step. You can just say the exterior angle is equal to the opposite interior angle. So the angle that's opposite the one next to it on the inside. Okay, so Y is 103, exterior angle of cyclic quad. And then to find Z, you could have used opposite angles of a cyclic quad here if you wanted to, I think, which is what I wrote down, yes. Or you could have used co-interior angles again, right? You could have done that as well. These two should add up to 180, both of them, because of the U shape, right? So you could have said co-interior angles, parallel lines for that one as well. Okay, how are we feeling about cyclic quads? I just see that they aren't actually, let's just quickly look at this example. Yeah, I just wanted to show you guys the example, which is also in the notes. I wonder if we should draw it. I don't really feel like it. And I think you guys probably also won't. Okay, let's just look at this example. It's not, I don't know, is that clear enough? Can you actually see what's going on there? Maybe we should not draw it. Okay, let's just do it. Let's be proactive. Let's stay away from this one. All right, so let's write converse cyclic quad theorems practice. Okay, you can obviously just use like a print thing if you want for the circle, but I'm just going to draw using this. Oh, now I lost my center. Okay, there. More reasons.
Next year first, no, what's the first?
Oh, I'm gonna write some stuff down. And I'm gonna start coding it out. I'm always so nervous when I'm drawing these. I don't know why. I'm like worried that they're not going to work out, I suppose. Okay. Well, this is erasable pen at least, which also helps. The worst is when like certain things are supposed to line up and then you've done the whole picture and then they don't line up. Okay. I'm just zooming in a bit. I'll zoom out when we're done drawing it. I think that is the whole thing. Guys, can I zoom out there so that you can see what I'm writing as well? Okay, what I did there was I just colored in BEFG so that we can see exactly what we're looking at there. They want wanting us to prove that that pink shape there is a cyclic quad. Now, this is what I was trying to say yesterday to the other group when we did that note, where I said that a cyclic quad is a quad with all 4 points on the circumference of a circle, whether that circle has been drawn or not. Okay, so if we're looking at the circle, obviously it's not going through those 4 points. So we can't just look at that shape and say from the start it's a cyclic quad. All right, but if that shape has the properties of a cyclic quad, which we're going to see now, if we can prove that, then we could technically draw a circle going through those 4 points, which I think also I said in yesterday's lesson, it's not drawn to scale necessarily, so you might not actually be able to physically draw it in, but you need to be able to kind of imagine.
Now, what is the proposed properties of a normal quadrant?
Well, I mean, a cyclic quad can also be a square.
Yeah, because
Or-
theoretically, if this is correct, if it has correct properties, would that mean it's a cyclic quad as well?
No, so a cyclic quad is like a quad on its own.
Okay.
Yeah, so it has specific properties that a kite might not have.
Okay.
All right. So guys, the two properties that we know of a cyclic quad is that the opposite angles are supplementary, they add up to 180. So what that also means, because we know that whether this is a cyclic quad or not, the 4 angles definitely have to add up to 360. Right? We know that about any quad. All right. So if we can prove, for example, that this angle plus that angle is 180, then these two angles will automatically also have to add up to 180 because the 4 angles add up to 360. Okay, so that's one property, that the opposite angles are supplementary. So we can see if we can maybe prove that. The other property is that the exterior angle is equal to the opposite interior angle, and we know that they're linked. All right, that second property actually comes from the first one. But sometimes we'll be able to prove that second one, and then we can also say that it's a cyclic quad. So guys, let's just quickly check here. Everything that's listed here, is it filled in on the picture? If D bisects CDE, CDE. All right, so this line actually cuts this angle in half, meaning that this one must actually also be X. Right? Does that make sense? If the line is cutting that whole angle in half, then the two parts must obviously be equal. Okay, so that's listed there. And it says that DG is perpendicular to AB. All right, now guys, that means that all 4 of these angles around this point will be equal to 90 degrees. So that gives us something to start with, right? That angle there is 90. And that is one of the interior angles of the cyclic quad. Now, find out maybe prove that angle E is also equal to 90. Because if I have that, then I can say that they add up to 180. Angle E. Why is angle E 90 degrees? Jasper?
Because the angle is subtracted by the diagonal.
Yes,
And
they
also
told.
we can apply the logic to F is also equal to the quad.
Oh, yes, we could say that. Yeah. Okay, but sorry.
Yeah.
You kind of lost me there. And then okay. All right. So just first things first here. This angle is 90 degrees, right? Because it is subtended by the diameter. They're telling us here that CD is a diameter. And we know that any angle at the circumference subtended by a diameter is equal to 90 degrees. So if this one is 90 and that one is 90, what is the sum of those two? 180. All right, there we go. So let's write that down. Angle, let's call it AGD. You only have to do one proof, but I'm gonna, what do you mean for this question?
Yeah.
Yeah, you would only have to prove it in one way, but we are gonna write the other way now as well, just so that you have it. So AGD is equal to 90 degrees. That was actually given, but just so that you remember, if you're looking back at this was because they said that DG is perpendicular to AB. You wouldn't have to write that as your reason, it's just for you guys to remember. All right, then we said that angle E is also equal to 90 degrees. That was angle in semicircle. Or you can say angle subtended by diameter, but it's obviously a longer one, so I can put this one. Therefore, now guys, unfortunately, you have to write this step down. You have to show that they add up to 180, because if we just leave it as this one is 90 and this one is 90, it might look like these things because they're equal. It's a cyclic quad. Right? You get what I'm saying? So you have to prove to the marker that you understand that it's actually the sum of the two that must equal 180. Because if the one was 70 and the other one was 110, it also would have worked. All right? As long as the sum is 180. Therefore, DEFG is a cyclic quad. And now we're going to use a converse reason. Okay, we proved that the opposite angles are equal to 180. So now we're going to say converse op angles of cyclic quad. Or you could say op angles of quad. If you don't use the word converse, you can't use the word cyclic in your reason. Okay, so if you're saying converse, then you're going to say converse opposite angles of cyclic quad. But if you don't use the word converse, you just have to say opposite angles of quad equal 180 degrees. Right. I would suggest that you just say converse, then you're actually just learning one reason and you're just putting the word converse in front of it. But it's very important that this reason is next to this line. If you write this reason in the top line, you're not going to get that mark. Okay, I'm going to say that again. This reason has to be written next to the line where you're saying that it is a cyclic quad. I mark matric finals, I mark paper 2, and often they write it in the previous line because they're used to saying, oh yeah, if it's a cyclic quad, then the angles will equal 180. But that is not the reason for us saying this here. The reason for us saying that they equal 180 is because we have that they're both 90, all right? So this reason has to be in this line. If you write it further up, you're going to lose that mark. Okay, so maybe underline this whole statement. It has to go together. The statement that it is a cyclic quad and that reason. You can't separate those two. Okay, there was another way of proving this. Isn't this angle G1 also 90 degrees? Right, all four of those angles are 90. And isn't G1 an exterior angle of the quad? Right, because it's one of the side lengthened. So the exterior angle is actually equal to the opposite interior angle as well. So we could have used that. So let's write here, or G1 equals 90 degrees. Same reason as above. Again, you wouldn't have to state this. It's just a reminder of where that's coming from. And you would have to say that E is also equal to 90, because this is now like an alternate solution. All right, if you didn't use this one, then this would be your answer. Angle in semicircle. Therefore, G1 is equal to E, right? If you want to use the exterior angle reason, you have to prove that they're equal to each other. Therefore, DEFG is a cyclic quad. Converse exterior angle of cyclic quad. So again, the same reason, but we just put converse in front of it. All right, so when we're proving that it is actually a cyclic quad, then we need to put the word converse in that reason. If they tell us that it's a cyclic quad, then the word converse is not there. Okay. Again, the reason and the statement should be in the same line. Yeah, the angle of E. Okay. E, we're just going to do that one very quickly. If angle EDF is equal to X, determine 3 other angles equal to X. Now guys, we actually already found another angle that's equal to X. We've already filled it in on our picture. This angle EDF that they're talking about, that's the X angle that was given, right? That one there. EDF is this one. Now they're asking for 3 other angles equal to X. We already said that this one is X. Okay, why was that again? They told us if D bisects CDE. So that's our first one. D1 is equal to X, and that is going to be your reason. Right? If D bisects CDE. You could, I suppose, but just because it's the example, let's write it down in full so that we know where it's coming from. So if D bisects CDE, okay, now we need to find 2 others. Now guys, we're actually going to have to now use our imagination to find the other 2, all right? Because when we proved that this is a cyclic quad, we need to now remember that we can use properties of a cyclic quad. Did we prove that it is one, all right? If it is a cyclic quad, then that means that these 4 points lie on the circumference of a circle. We just can't see that circle there, all right? So what does that mean? That means that DG is a chord in that circle because D is a point on the circumference and G is a point on the circumference. Does that make sense? So that would make DG a chord. It would also make FG a chord, right? Because both of these would be points on the circumference. If it's a cyclic quad, that means that all 4 points lie on the circumference of a circle. So FG is a chord. Now guys, do we notice that FG is then subtending angle D1? And isn't D also on the circumference of this imaginary circle that we can't see, right? Because these 4 points lie on the circumference of a circle. So we can say that FG is in fact a chord in that new circle, and it is subtending angle X at the circumference. But guys, isn't E also at the circumference of that new circle then? Because all 4 of these points are on the circumference of this new circle, meaning that GF or FG is actually subtending E1 as well. So E1 is also going to be equal to X. Right? FG is a chord in a new circle, so that's not one thing. That's one thing, we need to use our imagination. And then FG is subtending this angle at the circumference and that angle at the circumference. So they will be equal. What's the reason for that? If the same chord is subtending angles, angles indenting. Okay, so that's one. Can't we find another one? Let's see. FE or EF is actually also a chord on that new circle, in that new circle, right? Because these 2 points are on the circumference. This chord is subtending that angle X. And it is also subtending G2. So G2 is also going to be equal to X. Also because of angles in same segment. Right, so that's difficult, guys. Actually having to first prove that it's a cyclic quad, then use the fact that all of these lines are now actually chords in a circle that we can't see. And all of the angles that are going to be subtended at the 4 points of the cyclic quad that we proved, all of those angles are now at the circumference, even though we can't see that circle. Okay, so that's very high level stuff. So what did we say now? E1 and G2. E1 is equal to X and G2 is equal to X. Angles in same segment. Right, and then we have 3 angles. Okay. I'm going to give you a question from exercise 4 in your textbook, which one I'm going to give you. So you can write exercise 4, page 200, so long. Number 3. So exercise 4, page 200, number 3. All right, I am going to mark this with the other group on Monday, so you'll have to watch the video for the answers to that. But if you want me to discuss it a bit more on Tuesday with you, then you can just ask. All right, it's not a problem. I just want to show you quickly what number 3 looks like. They've given you this picture. All right, so we can see that that definitely is a cyclic quad. All right, because the 4 points lie on the circumference. But then we have another one here, which isn't as easy to see. AEDB. Right, check, do you see that? A and E and D and B. Those 4 points lie on the circumference. So this is actually also a cyclic quad already. Okay, so that's the answer to 3.1. And then they're asking you all sorts of questions afterwards. Okay, they haven't given us any values here, guys. They are just telling us some information here at the top. Please read through that. And angle F is X. All right, that is shown. So it's like the example we just did. We're going to work with X's in order to prove all of the things that they're asking us to. Okay, thank you, guys. You are free to go. I hope you have a lovely weekend. Yes, Lisa? Sure. There you go. No problem. Thanks, guys. Have a nice weekend.